Hello students. Now I am going to talk about differential equations of a higher order under the concept advanced calculus and numerical methods. So here I am going to talk about the particular integral of type 1. Type 1 is related to exponential term is of the form e to the power ax. Suppose in RHS in a given differential equation RHS term is containing exponential term is of the form e to the power ax means how we can solve that equation. So here some procedures we have to follow. So to find out the particular integral e to the power ax divided by f of d. Exponential term they given means we have to replace d by a. A means the coefficient of x in the exponential term. Here we have to remember that denominator should not be equal to 0. If the denominator is 0 means then we have to apply the ordinary rule. What does mean by that ordinary rule means numerator is multiplied by independent variable x and the denominator should differentiate with respect to d. After differentiating we are getting f dash of d. Once again you just replace d by a so that f dash of a. Again denominator should not be equal to 0. Suppose denominator is 0 means once again we have to apply the same procedure. Like numerator we have to multiply it by the independent variable x and denominator one more time you just differentiate with respect to d and replace capital D by a. So finally we should get some finite term in the denominator except that 0. So this is what procedure we are using to find out the particular integral of the type 1 exponential term is of the form e to the power ax. Now we'll see this problem d square minus a square into y which is equals to e to the power ax minus e to the power minus ax. Here solve, it means we have to find out the general solution of y. So first we should find out the complementary function and then we'll go for finding the particular integral. So d square minus a square into y which is equals to 0. First we should write the auxiliary equation. Replace d by m. So m square minus a square which is equals to 0. M is equals to plus or minus a. Here I term is not there. One is plus a and the one more root is minus a. So roots are real and different. So that the complementary function of y can be written as c1 e to the power ax plus c2 e to the power minus ax. Now complementary function is over. Now we'll go for finding the particular integral. E to the power ax minus e to the power minus ax divided by d square minus a square is there. First we'll do the segregation of this. We'll split this as a two terms. So after that the first term we have to replace d by a. If we replacing d by a in both the terms means we are getting denominator as 0. So we'll apply the ordinary rule. Numerator is multiplied by the independent variable x and denominator we have to do the differentiation with respect to d. So d square will become 2d in both the terms. So x e to the power ax will replace d by a, 2a. Similarly in the second term x e to the power minus ax divided by minus 2a. After replacing that minus into minus will become a plus. So we are getting solution as x e to the power ax plus x e to the power minus ax divided by 2a. So this particular integral, after getting this, next is we should write the complete solution or general solution of the given differential equation, that is sum of the complementary function and particular integral. The obtained complementary function and particular integral we have to substitute. c1 e power ax plus c2 e to the power minus ax plus x e power ax divided by 2a plus x e to the power minus ax divided by 2a. This is what our required solution. Now we'll see the one more example. d square plus 2d plus 1 into y, which is equals to e to the power minus x. First we should write the auxiliary equation so that it will become a m square plus 2m plus 1 equated to 0. On solving that quadratic equation, we are getting roots are minus 1 minus 1. Roots are real and same. So that complementary function can be written as c1 plus c2x e to the power minus x. After getting this complementary function, now we'll go for finding the particular integral. E power minus x divided by d square plus 2d plus 1. Here you just replace d by minus 1. After replacing that, if you simplify the denominator means we are getting 0. So we have to apply the ordinary rule. Multiplied by numerator by the independent variable x and denominator do the differentiation is with respect to d. It will become 2d plus 2. Now you just replace d by minus 1. After replacing that, once again we are getting denominator as 0 only, because minus 2 plus 2 will get cancelled. We are getting 0 in the denominator. Once again we'll apply the ordinary rule, that is x square e power minus x divided by 2. So here after getting, somehow denominator we got the finite term. This is what our required particular integral. Now we'll write the general solution of y as yc plus yp. The obtained complementary function and particular integral we have to substitute in this formula, so that y can be written as c1 plus c2x e to the power minus x plus x square e power minus x divided by 2. So now we'll see the one more example. So that is d square y by dx square minus 4y, which is equals to cos hyperbolic of 2x minus 1 plus 3 to the power x. First we'll write the auxiliary equation m square minus 4, which is equals to 0. On solving this equation we are getting m equals to 2 comma minus 2. So complementary function can be written as c1 e power 2x plus c2 e to the power minus 2x. Now we'll go for find the particular integral. So cos hyperbolic of 2x minus 1 plus 3 to the power x divided by d square minus 4. Here we'll convert this hyperbolic function in terms of exponential term with the help of formula, and 3 to the power x you just write as it is. We'll make this as particular integral 1, 2, 3. Now one by one we'll find out. The first one, 1 by 2 exponential term e to the power 2x minus 1 divided by d square minus 4. Because of exponential term, replace d by a means here 2. After replacing, denominator term will become a 0. So we'll apply the ordinary rule. After applying that, after small simplification, we are getting particular integral 1 has x by 8 e power 2x minus 1. Similarly, particular integral 2 also we have to find out. Here only thing is replace d by a. Here the value of a is coefficient of x in the exponential term, that is minus 2. So after simplification we are getting particular integral 2 has minus x by 2 e to the power minus of 2x minus 1. Now we'll go for find the last one, particular integral 3 to the power x. This is not an exponential term. Now we can convert this as exponential term by making that term as e to the power log 3 to the power x, so that this will become e to the power log 3 into x. Here the coefficient of x is log 3. That term only we have to replace in the denominator. Replace d by log 3. Log 3 is a constant term. After replacing, we are getting solution as 3 power x divided by log 3 whole square minus 4. After getting p1, p2, p3, substitute in the formula. So that we will get the particular integral. That value we have to substitute in the general solution formula, that is y is equals to yc plus yp is the required solution. So here y equals to c complementary function and then particular integral we have to substitute in the respective place. This is what our required solution. This problem just I given for you people for a practice. d square y by dx square minus 6 dy by dx plus 25y, which is equals to e power 2x plus sin x plus x. So first find out the complementary function and then particular integral. We will get this solution. You just take a practice for this problem. Thank you.